Okay, question 6. You see dy by dx, so you should be thinking to yourself, this is a differentiation question. Now, we differentiate, we need to set the things up first of all. So we should be looking for something like, y is equal to x squared plus a half x, take away a third x to the minus 2, something like that I can differentiate. We've got a bracket there. Now, what I could do if I've got a bracket, if I had x plus 2 squared, I could multiply that bracket out. I can say, okay, well, I've got x squared plus 4x plus 4, and then differentiate. Okay, so that's fine. But what if I've got something like y is equal to x plus 2 to the 5? There's quite a lot of breaking out to do there. That's quite annoying. What if I've also got something like y is equal to x plus 3 to the half? Ooh, that's quite a complicated bracket. How would I break that out? So when you've got these cases, you're thinking to yourself, it's going to be my chain rule. Okay? So it's the same kind of idea. We have to still set up first, but then we'll apply our chain rule, and that will make integrating just as easy as this, really. So change the sign when you cross the line. So first thing I'm going to do is bring up that 5 and call that negative 5. Okay? Now what we're going to do is differentiate the outside of the bracket just the way we would a regular function. Okay? So I'll just put this on the side just to kind of give you an idea. So say that was y is equal to, and I'll call it u, so it's a different letter to the negative 5. If I want to differentiate that, I'd say, okay, well, that's dy by dx. So when I differentiate, I multiply, and then I take 1 away. So take 1 away from that, I'm going to have negative 6. Okay, so multiply, take 1 away. I'm going to do the same over here. I'm going to say dy by dx. That's going to give me negative 5 to the negative 6. Now my bracket stays exactly the same. So I put that in there. And then I need to, and this is my rule, I need to multiply by the differential of the bracket. So that's the bit that people forget. So I'll tidy that up. Negative 5 times negative 3 is going to give me 15. And 1 take away negative 3x to the negative 6. I could tidy that up further. Keep the 15 on the top. 1 take away 3x to the power of 6. And that's us finished. So you don't have to tidy up like that, I don't think. What you're getting your mark for is a setup, 1 mark for that. Differentiating the outside, tick, and then multiplying through by your differential, tick again. So quite a nice little question, actually. And again, I do think it's worth learning these because there's only so many ways they can ask you this new skill, Things like differentiation and integration in the regular sense, that gets tied into more contextualized questions, which can be a bit tricky sometimes. But this is just a very straightforward skill. Do you understand how to differentiate and integrate composite functions? Yes, I do. I'm going to apply the chain rule or the inverse chain rule. So great question to do. Just take your time, and like I said, you're differentiating the outside and then multiplying through by the differential. You only have to use this when you've got kind of funky brackets, okay? All of these would be much easier just to do in separate pieces. And in fact, the other thing I'll say as well, people seem to get this confused. If you've got something like x cubed, plus 2x squared plus 4, all divided by 3, remember, that's the same as x cubed divided by 3, plus 2x squared divided by 3, plus 4 divided by 3. Remember that as well, okay? And that's part of your setup for the regular differentials as well. Hope that's helpful.